Now, new data reveal the interstellar interloper to be a rocky, cigar-shaped object with a somewhat reddish hue. The asteroid, named Oumuamua by its discoverers, is up to 1/4 mile, 400 meters, long and highly elongated, perhaps 10 times as long as it is wide. That aspect ratio is greater than that of any asteroid or comet observed in our solar system to date. While its elongated shape is quite surprising, and unlike asteroids seen in our solar system, it may provide new clues into how other solar systems formed. The observations and analyses were funded in part by NASA and appear in the November 20 issue of the journal Nature. They suggest this unusual object had been wandering through the Milky Way, unattached to any star system, for hundreds of millions of years before its chance encounter with our star system. For decades we've theorized that such interstellar objects are out there, and now, for the first time, we have direct evidence they exist, said Thomas Zurbuchen, Associate Administrator for NASA's Science Mission Directorate in Washington. This history-making discovery is opening a new window to study formation of solar systems beyond our own. Immediately after its discovery, telescopes around the world, including ESO's Very Large Telescope in Chile and other observatories around the world, were called into action to measure the object's orbit, brightness and color. Urgency for viewing from ground-based telescopes was vital to get the best data. Combining the images from the FORS instrument on the ESO telescope using 4 different filters with those of other large telescopes, a team of astronomers led by Karen Meach of the Institute for Astronomy in Hawaii found that Oumuamua varies in brightness by a factor of 10 as it spins on its axis every 7.3 hours. No known asteroid or comet from our solar system varies so widely in brightness, with such a large ratio between length and width. The most elongated objects we have seen to date are no more than 3 times longer than they are wide. This unusually big variation in brightness means that the object is highly elongated, about 10 times as long as it is wide, with a complex, convoluted shape, said Meach. We also found that it had a reddish color, similar to objects in the outer solar system, and confirmed that it is completely inert, without the faintest hint of dust around it. These properties suggest that Oumuamua is dense, comprised of rock and possibly metals, has no water or ice, and that its surface was reddened due to the effects of irradiation from cosmic rays over hundreds of millions of years. A few large ground-based telescopes continue to track the asteroid, though it's rapidly fading as it recedes from our planet. 2 of NASA's space telescopes, Hubble and Spitzer, are tracking the object the week of November 20. As of November 20, Oumuamua is traveling about 85,700 miles per hour, 38.3 kilometers per second, relative to the Sun. Its location is approximately 124 million miles, 200 million kilometers, from Earth, the distance between Mars and Jupiter, though its outbound path is about 20 degrees above the plane of planets that orbit the Sun. The object passed Mars' orbit around November 1 and will pass Jupiter's orbit in May of 2018. It will travel beyond Saturn's orbit in January 2019. As it leaves our solar system, Oumuamua will head for the constellation Pegasus. Observations from large ground-based telescopes will continue until the object becomes too faint to be detected, sometime after mid-December. NASA's Center for Near-Earth Object Studies, CNEOS, continues to take all available tracking measurements to refine the trajectory of 1I 2017 U1 as it exits our solar system. This remarkable object was discovered October 19b.